right, good afternoon, everyone. Welcome to my talk about the future of C# and Visual Basic. My name is Bart de Smet. I'm working as a developer in the SQL division back in Redmond. And it turns out I've been dealing a lot with asynchrony lately. I've been working on reactive extensions, which is an event processing system. And it turns out that the features that we have in C#5 and VB11 is really very useful and very complementary to that. So today I'd like to talk about, well, what's new in C#5 and VB11, and also take a little look at something coming after that with Project Roslyn. So what's the agenda for today? Obviously, we'll talk about C#5 and VB11, which are the releases that come in .NET 4.5 and Visual Studio 11. Next, we'll talk about writing hybrid applications that use managed code and interact with the Windows 8 Windows runtime. We'll actually have a separate talk about Windows runtime, but I want to sort of whet the appetite of the audience with a little demo of that as well. Next, we'll also talk about the Roslyn project, and most and foremost, we'll actually talk about the main theme of this talk, which is asynchronous programming, and we'll see that actually stretches basically the whole talk in terms of, occurring in a lot of places, because asynchrony is really becoming the norm. So before we get started, I wanted to take a look back before starting talking about the future. So I still remember the day that Microsoft introduced managed code, which is about over 10 years ago. I was just about to start studying at the University of Ghent, and later I became an MVP for C# and ultimately joined Microsoft in 2007. So it's been a long time that we've had managed code, which was introduced, of course, in .NET 1. In .NET 2, we basically did the things we didn't quite get around to do in .NET 1, including generics, nullable types, but also a little feature called iterators in C# 2.0, which turns out to be very applicable to the stuff we're doing with async programming. In fact, the compiler transformation that drives asynchronous programming is pretty much the same as iterators. And we'll see that iterators now are also added to VB11. Next, somewhere around 2005, we did language-integrated query to solve the impedance mismatch between object-oriented systems and all sorts of data, whether it's relational databases, in-memory databases, XML. And then the last release, C#4 and VB10, we did, as the main theme of the release, dynamic programming with the dynamic language runtime, Iron Python, Iron Ruby, those kind of things. And we also introduced this new theme called language parity. It didn't make sense to have two different language flavors, VB and C#, that had different features. And so language parity was introduced as a commitment to make every feature appearing in C# also appear in VB and vice versa. And so you'll actually see some additional language parity added in 5.0. So in C#5 and VB11, the main theme is asynchrony, writing asynchronous programs, which has been notoriously hard, as well as support for the Windows runtime in Windows 8. So let's start with the little menu. The menu, those are all the features I will talk about. Asynchronous programming, obviously. Windows runtime support, very briefly. Some little feature we got around to do thanks to the work done in .NET 4, thanks to having optional parameters and named parameters. We can do something called color info attributes, really a minor feature. And then in VB11, we also added parity with C# by bringing C# 2.0 iterators to VB11 as well. So let's get started with this big theme of this release, asynchronous programming, and take a look at what's really up with that. So it shouldn't be a surprise anymore to anyone here that asynchronous programming is the norm of writing applications today that are connected, that need to be fast, fluid, responsive, all those kind of qualities. So when you write Windows Phone apps, you have to be asynchronous to talk to certain APIs. When you will use the Windows runtime in Windows 8, there are even no synchronous APIs for certain operations anymore. You have to go asynchronously. And that holds true for client applications, phone factor, tablet factor, desktop applications, as well as server applications. If you look, for example, at ASP.NET, we actually have had asynchronous support since day one. And now you see big frameworks like Node.js actually surfing on top of the success of asynchronous programming to make web servers more scalable. So it's not just a client-side thing, it's also a server-side thing. So here's a little reminder of what we mean with synchronous versus asynchronous programming. At the top of this slide, I have some piece of synchronous code that first will download some data with some parameters. And then once the data is downloaded, it will feed it into some call called process data. And so when we look at the timeline of the execution of this piece of code, we see that when we call download data, we basically block the thread till the data becomes available, and then we can do process data, which definitely is not a good idea. For example, if you run a UI thread, the whole thing starts frosting over, and you get a Snow White effect in Windows. At the bottom of the slide, there is some sample of how you could do asynchronous programming. Now what I have is download data async, given the same set of parameters, but it doesn't return the data straight away. Instead, what it returns is an object, a future object, that somewhere in the future will hold the value of the operation. Now, how do you fish that value out? Well, you could block on that operation by doing something like .wait, but then you're back to slide, or the thing at the top of the slide. So what do you do instead? Well, you do something called continue with. You pass in a continuation, a callback that says when the operation completes, continue executing code that's specified over here. And so the execution scheme starts looking slightly different. You do download data async, and then after hooking up the continuation with continue with, you just return to your caller, which might be the UI message loop, and it can do other things in the meantime before ultimately the process data call completes and the continuation is scheduled. And that continuation then goes back to the UI message loop and renders the data. Now, an additional benefit, besides the fact that if you block the caller, that does this download data thing, is also that you can add parallelism. You can overlap multiple operations thanks to being asynchronous. And that's where the efficiency in web server software comes from when you do asynchronous programming. You can basically yield the thread, and somebody else can come in on the same thread to do some other request. So that's what you're seeing here. If you do two calls to the containing method where we do download data and process data, you will actually have, in the synchronous case, twice the amount of time. Now, if you look at the bottom case and you call this method twice, you can basically have multiple outstanding process async calls and download async calls that are actually in flight at the same time. So that actually allows you to do much more useful stuff on the thread. So what's the key observation now with making asynchronous programming easier in the language? What can we do about making this piece of code actually look nicer? So first of all, we have many ways of representing asynchrony in the .NET framework, in the Windows runtime, in JavaScript. They're just different ways of doing the same kind of thing. In the .NET framework, we have task of T since .NET 4. In the Windows runtime, we have an interface called iasync operation of T. And in JavaScript, people prefer to work with promises. Now, all of those things happen to be the same thing in disguise. They're all objects that represent some operation that's in flight. You can actually walk up to a task of T that's doing some download operation and ask, what's your status? Are you running? Are you cancelled? Are you faulted? You can even block for the operation to complete, which generally is a bad idea. But so you can walk up to that object and sort of ask what it's doing. Now, the main operation you do with those objects is actually hook up a continuation. You say, when the operation completes, please continue executing with this piece of code that gets automatically scheduled after the call completes. So you have to use callbacks. Now, unfortunately, callbacks tend to turn your code inside out. Like you start with an operation, you do some download, and then you have a continuation, which all of a sudden is a lambda expression or a delegate that continues executing the rest of the code. So your code doesn't at all look sequential anymore. And now, what if you want to put like a try-catch handler around all of that stuff? Like, where does the try-catch run? What does it protect? Does it protect starting the operation or completing the operation? You have to duplicate the try-catch thing outside the continuation and inside. How do you do a loop with this whole thing? Like, it gets hairy really quickly. So the insight that we leverage in C#5 and VB11 is that the compiler is really good at doing this monkey business of transforming code. You just write your code linearly with while loops and for loops and using statements and try-catch finallys, all that you want. and we will actually turn your code into little blocks of code that are scheduled as continuations with the operations. And so basically, what we build out of an asynchronous method is a state machine that the compiler can generate really efficiently. But if you have to do it yourself, you're basically tearing your hair out. So this is the key insight. If you walk out of this talk, that's the main thing to sort of remember is what the compiler really does is what you would have to do yourself if you wouldn't have async methods, and it turns out it's pretty nasty. So let's actually take a look at an example. So what I have here is an async method in C#5 called getXMLAsync. Now, what are the key observations that, by just looking at the signature, reveal that it's an async method? Well, first of all, some naming convention, we end those methods with async. But secondly, it doesn't return an X element. It returns a task of X element. So it's an object that represents the ongoing operation of, in this case, getting the XML from a web request. And ultimately, you want to do a continue with on that thing to execute the rest of the code. Apart from the fact that you don't want to use continue with anymore, but you want to use the new language features. Now, inside this method, there's one keyword that looks a little interesting. It's this await keyword. So what's that await keyword have to do with this async method? So first of all, when you mark a method as async, it tells the compiler, please transform this method on my behalf into callbacks. Like every time you hit an await point, where you are doing some asynchronous operation, the compiler will say everything that goes below the await becomes a continuation, becomes a callback. So it basically cuts up your code in little pieces. Pretty much the same as what the C# compiler has always done for iterators in C# 2.0. When you do yield return, yield break, it's really creating a state machine between all the two consecutive yield returns. Here it's doing the same thing for consecutive awaits. So what happens when you execute this piece of code? When you call getXMLAsync, we create an HTTP client, and then we start some asynchronous call on the client. We say getAsync of URL. Now that thing returns a task, which at that point will not be completed yet. It's doing the request. So the compiler says, well, at this point, I want to return this task of X element as soon as I can, and I will lift the rest of the method into a callback that's registered with this getAsync call. So this is really how the transformation sort of looks like. It's much more complicated than that. It has a switch statement with, a state machine in it, and it also does some exception handling stuff, but this is conceptually what it looks like. First of all, we knew up a task completion source. And what's a task completion source? It's a factory for those task objects. It's something you can ask, please give me a task. But the second thing you can do with it is, in the future, you can kick that task in the back and say, the value is ready, please run your continuations. So it's sort of a two-sided animal. You can actually ask for a task and you can signal the task. So we have this task completion source. Up to the first await point, we were creating the new HTTP client. That still happens. And then we do client.getAsync, and now all the rest of the code that is below the await point gets lifted into a callback. So we have continue with, when the getAsync completes, that little piece of code is executing. And where there used to be a return statement in the original method, now we don't longer return, because returning from the continuation doesn't do any good. It's running on a thread pool thread or wherever it's going. Instead, what we do is we say to the task completion source, the result is ready, by saying set result. And so we actually feed that data in. And in the main method, we just return the task, which might not be completed yet because the continuation will run in the future. And so when this set result happens, the continuations start executing, and somebody else higher up the call stack who did an await on this method, somebody might be doing an await getXMLAsync, will then continue running the rest of the method. So it's basically a way to orchestrate this asynchronous programming, which you otherwise have to do yourself. So let's take a look at a little demo here. Let me switch machines really quickly and have a look at a little example. So I'm actually running the Windows 8 developer preview here. I'm not going to show a Windows 8 demo just yet. So I'm just going to use VS11 for desktop applications. And actually, that's the wrong project. That's the second demo. So this would actually be a Windows 8 demo. So let's actually open the Netflix CS project and take a look at the code we have here. So what we want to do is we want to write a UI application that allows us to look at the catalog of movies on Netflix. And so we have a synchronous version of the code. We have an asynchronous version using what's available today in .NET 4. And then we have one that uses the await keyword in C# 5 and VB11. So let's actually open main window.xaml.cs and actually boost the font size a little bit. So really what's going on here is not too much of a mystery. We have some movie class that has some properties. We have some OData feed where we can actually get movies from. That's this URL sitting here, odatanetflix.com, with some filter. And ultimately, we have a main window. We have a search button, which calls a method called load movies. And there's a little remark here that we can't do something in the synchronous case. I will come back to that in just a second. But so load movies does the following. It actually clears the results panel on my UI. And then it starts a loop that actually gets batches of 10 elements from Netflix, because they don't allow you to download the whole thing in one go. You actually have to do some batching. And OData supports batch-style operations, so everything is fine. So we have a while loop, and inside the while loop, well, we basically say where we want to start, the first element on the page, and then we say download 10 elements at a time. So we get movies 0 to 9, 10 to 19, and so forth in this little loop until we don't get any elements back, meaning that we drain the whole catalog. So this query movies thing, what does that look like? Well, queries movies, as you can see, is a synchronous method. It returns a movie array given a year and then the first element and the count of the number of elements on the page. This cancellation token here isn't really doing much because a synchronous call you can't really cancel. If you call it, it's already too late to cancel it. So this is sitting here to contrast later that we can wire up cancellation really easily in C# 5 using the await keyword. So what's the big problem with this piece of code? Well, it's this line. We're calling client.downloadString, which ultimately happens on the UI thread and blocks till we get the data back. And so as we try to execute this thing, it's really bad, in fact, because we are just sitting on the UI thread, we're doing this download thing. Around that we have a while loop, and in fact the while loop doesn't even get a chance to update the status tags. Why is that? Because when you use status text.text and you assign to it, it really posts a message to the UI loop. But we're still running this while loop. Like, ultimately, that message loop will see all the searching with element count, things coming back, but they will only be executed after we've done the whole while loop. So we're even not noticing progress in the UI. So I can try to execute this piece of code. And in fact, it's really pathetic because you have to sit here and wait for a long time before this thing completes. Like, the app is not responsive, I can't move it. Ultimately, it will frost over if Windows notices that the UI loop is not responding. Like, it's really a bad experience. We don't want this for touch. And in fact, this is a touch machine. I can tap on this machine all I want. It doesn't do anything. So, bad experience. Let's actually kill this thing. And take a look at how we would restructure this code that we have sitting here, this load movies and this query movies method, with the tools that we have today. How would we basically turn this into asynchronous code? And the answer is, it's not that easy. So here we go. Let's boost the font size again. And here is the code. So first of all, I'm doing some stuff with a timer here. We'll talk about that later to cancel the ongoing request if it takes longer than 20 seconds. Let's just ignore that one for now. But load movies async, oh my God, how does this piece of code look like? I don't quite understand anything of it. Well, what you're doing here is basically what the compiler has to do. If we look at this code, we new up some action that, given a movie array and an exception, does some stuff. If there used to be an exception, we're going to analyze the exception. We can't even use a try-catch around this whole thing, because try-catch is going to protect not the continuation, not your lambda expression that you pass to an operation. So you have to analyze exceptions not by using the catch keyword, but by doing type checks, all sorts of nasty stuff. Then in here, what we're doing is we're doing searching titles. If movie length is larger than 0, we're basically going to do display movies and query movies async. Now, look at this query movies async thing. It takes in the year, the image count, the page size, the cancellation token. But it also takes in an action. What's that for? That's how to continue after the current batch of movies is downloaded, what to do after that thing completes. What am I passing in here? The action that happens to be the same piece of code. So I have to lift my piece of code into an action that I then pass all the way down to the asynchronous operations. Like a lot of voodoo that you actually have to go through. And the query movies async now returns void. It's an async method, it returns void. But once it computes its result, it will call this action to continue executing. So it's a little bit like task and continue with. A task, given a continuation, can schedule that continuation at a later point. In this case, my query movies async method knows what to do when the result is computed. So in asynchronous programming, in a classic approach without async and await, you typically end up with those void returning methods that take in a delegate at the end. And you basically have to lift everything in this mode. And now if you look in this query movies async, this is also maddening. Like, just looking at it. The first piece of code you write on the web client is what to do when the download completes. So you start with the end of your program. You say what to do when the thing completes. And then if you scroll down all the way after the code that runs when it completes, oh, there we start the operation. So you have to do things in reverse. First hook up the continuation, then start the operation. And you end up with code that continues to indent, like it's not good at all. And don't even ask me whether the exception handling is completely working fine in this particular case. So not really what we want. So what do we do in C#5 with the await keyword? That's what we have sitting here. Let me actually boost the font once more. Instead of having load movies, the synchronous version, I now have load movies async. If I go into that one, it's, first of all, as you can see, an async method. This tells the compiler to start looking for those await points in the code and do all of that plumbing to transform the code on my behalf. And then just look at the code. It's exactly the same code as the synchronous version that I have sitting here. Load movies, if I can actually make the font similar, let's do 150% on both sides. Like if you overlay those two methods here, like this, async and the load movies method. Load movies async takes in a year, load movies took in a year as well. If I switch between those two things, what's changed to my code? Not much. I have the async keyword, and I have an await sitting here. Other than that, the code looks exactly the same. What the compiler does is make sure that when this query movies async thing ultimately completes, the next iteration to the loop is done. And you can put try catches around all of this thing. Exceptions are propagated the way they should. So ultimately, they just feel like synchronous code. You can use everything you're familiar with, like try catch, finally, using statements, for loops, for each loops, everything, link queries, everything just works. And so if I look into the query movies async method now, let's do that in the synchronous version as well. The query movies method used to return a movie array. Now it returns a task of movie array, which means eventually this thing will contain a movie array, and it has the async modifier on it. Other than that, the code looks pretty much the same. The only line that's different is this one. Client.download string originally now is client.download string task async. And this thing doesn't return, as you can see over here, it doesn't return a string, but it returns a task of string. And then you can await that thing, and ultimately the rest of the method starts executing when that task completes. And so looking between the two, that's the only thing you have to change, and now your code is asynchronous. So let's actually take a look at running this code. Set it as a startup project. 9097. Let's actually use some touch support here. And so you see movies are just ticking along and they're just being downloaded, 10 elements at a time. My UI is responsive. I can actually, click on a movie as well, it turns out. Or I can scroll through this whole list. So you see this whole thing is responsive. I can even click the cancel button. And because we wired that cancellation token all the way down to the underlying operations of doing the download, as soon as you hit cancel, that cancellation token propagates and the leaf node operations basically get canceled and the whole operation sort of bails out. So pretty simple transformation to do. Looking at synchronous code, making it asynchronous, async keyword on the method, await inside method. So let's switch back to the slides and recap what we just learned over here. Okay. So what are asynchronous methods really doing? Asynchronous methods, first of all, are marked with this async modifier. That's the indication for the compiler to start transforming your method based on continuations and callbacks. So you can actually put this async modifier on methods that return void, as well as task or task of t. So task of t is the obvious one. The void ones are very useful when you're writing asynchronous event handlers. Like if you double-click on a button, you get the void button clicked and the event args. Now you can make that an async method. Like it just works with the overriding rules in C#. You can put async on a void returning method. What that means, though, is that that particular method doesn't return an object that you can look at to see, is the operation still going? Is it being cancelled? You can't await that operation. Like if it's void returning, it's fire and forget. It's running, it's doing something. If it throws an exception, it will likely come out somewhere where it shouldn't come out. So that's the only caveat of those void returning guys. For example, if you want a grant cancellation, put some try, catch, task cancelled exception around that thing, because it doesn't propagate. The continuation at some point runs on the thread pool, and poof, mysterious things could happen. You can, by the way, also put the async keyword on lambda expressions. So you can have an async lambda, which means it's just a lambda expression of which the return type becomes task of t, or void. Inside those async methods, you use await, basically to yield control cooperatively. Say that you're on the UI thread and you hit an await keyword. What happens at that point is we hook up the rest of the method as the continuation, and then we start bailing out. We start returning from the current method. Like it just returns all the way, typically to the message loop that's doing a while peak message deep inside the UI framework. So you're basically yielding control, because at that point, somebody else can use that same thread to do UI processing. Or in the case of ASP.NET, somebody else can use that thread to basically process another request in the web server. So await basically yields control, telling the compiler that when this thing completes, please execute the rest of the method. And so that's really what's going on. The method sort of gets resumed when the awaited operation completes. The rest of the code starts executing. The await completes, meaning it returns a value, or it throws an exception. If there was an exception in completing the operation, it will just come out at the point where the await resumes, so you can put a try-catch around the await, and you're basically catching the exception. You can await anything that implements the awaiter pattern. So this isn't exclusive to task of t. In fact, we also have support for await on WinRT, Windows Runtime objects that use iasync operation. How do we do it? Extension methods. As soon as you have a getAwaiter method that returns an object that has an isCompleted property and uncompleted callback function, those elements, the compiler just binds against it. Just like in C# 1.0, the for each loop isn't tied to IEnumerable of t. As soon as you have getEnumerable and move next and current, it just works. The compiler picks it up and the for each loop binds to your object if it implements the right pattern. So that's the same for the await support. So you can await other types by just implementing the required methods, and the compiler just binds against it. In fact, in reactive extensions, the technology I'm working on, we have await support for iObservable of t as well. That's awaiting an event to happen. Next, an important thing here is that it also takes away the burden of doing manual synchronization with, for example, the UI thread. Traditionally, if you did web client and then you had download string completed and you hook up an event, where does that event run? Where does the callback run? Typically, it runs on the IO completion port, which triggers a thread pool thread to be executed, meaning you can't touch the UI, because if you touch the UI from a background thread, bad things happen in the world of STAs and WinForms and WPF and Silverlight. And in fact, in Windows Runtime, that's even the same. So what await does is, at the point we capture the rest of the method to resume execution, we also capture the current synchronization context. And when the method needs to be resumed, we post that continuation to the synchronization context that we started on. So in other words, if you do await download string async, when that string completes, the rest of the method runs again on the UI loop, or where you started. In the case of ASP.NET, it's basically the synchronization context that captures the information of the current request. So in other words, you come back where you expect us to come back. And in fact, you can configure the await pattern by doing something called configure await, where you can pass in a Boolean flag if you say, I don't want this thing always to come back on the same synchronization context. If you're fine with things migrating to different threads for performance or something, you can actually override this default. And in fact, Alex Turner has a talk tomorrow, I believe it's in room 10 as well, the Zen of Async, where he will talk about those tricks as well. Now, the good thing is that besides the fact that you need to know async and await, those two keywords, other than that, it's just regular expressions in C#. You just await some operation, you get a value back, and you can use it wherever you could use expressions. Like you could await an operation and multiply it times 2. It just works. The compiler splits up, starting the operation and then continuing execution by doing times 2. Like any old primitive in the language just works together with this feature. So it just feels like good old synchronous code. That's the nice thing about all of this. So are there any questions about the async support? I'm more than happy to take questions at this point. I will repeat them for the mics or for the recording. Nobody? Okay. So tomorrow there will be a talk about async support by Alex Turner. I strongly recommend you to go to that one as well. So once you've seen this async and await keywords, you will actually see how you can get even more out of it in terms of performance and all of those things. So next, let's talk a little bit about the support that we're adding to the language for Windows 8, Windows Runtime, Metro-style applications. So let's actually switch back to the demo machine and just give a little appetizer of the stuff I will talk about later today with regards to writing Metro-style apps in C# and VB. So what I have here is a little application that's written using the Metro template for JavaScript. So it's a JavaScript application. You see this Win.js stuff in here. And that's actually the library that you can use in those WinRT-style applications when you deal with JavaScript. Now, what I want to do in this app is I actually want to interoperate with C#. And that's one of the great things that the Windows Runtime provides you, is interoperating between C++, JavaScript, and those managed languages in those Metro-style apps. And so the app isn't really fancy yet, because I'm just populating this grid view with some default pictures and some default text. So I can actually show you how that works. Let's swipe in here and stop the debugger. What's really going on, excuse me, is I have an items array here, and I'm just running through a loop to push items in the array that contain a title and a URL. And then there is some data binding stuff going on in the markup, which is plain old HTML5 here, and it basically renders those things. And finally, I'm telling to the list view object, which I obtained over here by using getControl, what the data source is, that's the items array, what the renderer is, which is the template to render the individual boxes, and then I do an update, which basically refreshes the UI. So now I want to take this little piece of stub code that I have sitting here, and I really want to get some data out of C#. And again, I want to do it asynchronously, not to hang this application. So how can I do this? So in those applications, those Metro-style apps, you can add a new project. In this case, I will choose C# Windows Metro-style. And I will create a class library, which I will call data model. So here we go. We're just creating a class library. And that's a plain old CLR assembly class library that I have sitting here. Now, instead of compiling this thing to a .NET assembly, in order to use it from Metro-style apps, I just have to go to the properties dialog and change the output type from class library to WinMD file. WinMD stands for Windows Metadata. I have a separate talk on Windows Runtime at 5:45 this evening in room 8, and there we'll talk much more about WinMD files. In fact, they share the same metadata format as the CLR, so they're pretty, straightforward for people who've used managed code for a long time. And so what I want to do in here is actually getting rid of this class 1 file, and I'm just going to add an existing file I have sitting here in my documents called datamodel.cs. And so the data model file that I have sitting here basically has a couple of things. It has a struct, which has 3 public fields, title URL and box art URL. Those are the 3 things I want to send back to my other application. I'm just sending a little bit more. I'm not using the URL in my visualization yet, but you can envision my JavaScript app to have an on-click when you click on an item there and just browse to a certain URL. This is the code you saw before. It's actually the code that queries OData, very similar to the one we had in the UI application. And in here, I have a method called queryMoviesTaskAsync that takes in a year, first, and count, the usual business that we had before. It's an async method, which means I can use await inside, and indeed I'm awaiting a web request, meaning that while the web request is pending, I can just pause this method and continue with my UI work and later execute the rest of the code. And I'm returning a task that contains an iList of movie array. So that's what I'm returning over here. Movies2list returns a list of movie array, or list of movie, which of course also is an iList. So let me now try to compile this piece of code. And we'll actually hit a couple of errors. I'll actually explain those in my second talk today in much more detail. But essentially, to use managed code from Windows Runtime, your publicly visible members have to basically adhere to certain contracts. They cannot use any old CLR type. They have to expose things the right way. And in fact, there are only a few little things that you have to be aware of. First of all, public members have to be sealed, or public classes have to be sealed, because there's no cross-language inheritance story in WinRT. So what this means is my class cannot be derived from, and upon compiling the WinMD file, this thing is basically going to generate an interface that the other languages can talk to. So it's basically distilling an interface from my class implementation, because WinRT, in essence, is an interface-based system. Now, next what I have here is an operation that returns task. Task is a CLR type. It's not the way we do asynchrony in Windows Runtime. So I have to just create a little bridge method that converts the task in an async operation, which is the way that WinRT deals with asynchronous operations. So let me actually do that. Public iasync operation, operation of iList of movie. And iasync operation lives in windows.foundation, which is a Windows metadata file that ships with the operating system. So I'm just going to include the interface, and I'm going to call this thing actually the same as the one below. But it's not task async, it's just query movies async, like this. So now that I have this guy, I can mark this guy private, and now I'm going to return an async operation that internally runs the task, so a little adapter. And that's, in fact, one of the only places you have to write adapters. Other than that, your types just marshal across just fine. So I'm going to call async info factory over here. I'm going to say create, and I'm just going to return in the lambda the original task. So basically, async factory takes in a lambda that produces a task, and it moves it into the world of async operation. So year, first, and count, like this. And so with this, I'm actually ready. I can just try to compile this thing again. And it should work now. Build succeeded. And next, I can go to my JavaScript application and add a cross-project reference to my data model. What I'm doing over here, there we go. And now, inside the JavaScript, well, instead of doing all of this stuff, what I can try to do is I can actually new whip my data model from inside JavaScript. var nf for Netflix equals new data model, and you see we even get IntelliSense, cross languages. Now, my JavaScript is actually talking to my C# code, which has generated a WinMD file which contains all the static type info that we can use here. And in JavaScript, sometimes you get lucky with this IntelliSense stuff, and in this particular case you do, because, well, C# is statically typed. So now I have my Netflix object. Next, I want to do this query movies async thing. Here I'm passing in the year, 1997. Let's start at element 0 and get, like, I'll say 20 movies. Now, that's an async operation. How do I deal with that in JavaScript? In C# I would just call await on that thing, and ultimately I would get my list of movies back. In C++, you might want to do something else, because you can also write C++-style metro-style apps. How do you do it in JavaScript? Well, in JavaScript, people say, the way I want to think about those asynchronous operations is promises. And so in WinRT, there's this notion of projections that take those APIs and project them into something that feels familiar to the end users. By the way, also notice that my method in data model CS is called query movies async with capital Q. In JavaScript, the projection has taken it to lowercase q, which is much more familiar to JavaScript users. So the projections take the APIs and make them look and feel like the language that you're dealing with. So in JavaScript, lower cases, asynchronous operations become promises, iList become JavaScript arrays. So you can actually just interoperate with those guys the way you expect. So because it's a promise, in JavaScript you can write then, which is like continue with on a task, but the JavaScript way. So somebody who knows JavaScript can just walk up to this code and start writing, the continuation that says, when I get the movies, I want to render them. And so all the rest of my code, which you don't have to do in C# because we have await now, but all the rest of my code is registered as a callback. So now I get the movies, and then what I want to do is I want to render the items over here and update the layout. Of course, this piece of code goes away, which was just my stub to populate some sample data. And now what's this movies thing? This movies thing started out its life as an iList of t in the CLR. The way it actually projects in JavaScript is like a JavaScript array. So you can write things like map, filter, for each. All those functions that JavaScript people know that actually exist on arrays now are all of a sudden available by talking to this object. And so I have a little piece of code sitting here somewhere. I used to have a little piece of code sitting somewhere. Okay, so let's do it manually. For each function m, for each movie, I'm just going to run a little piece of code that now goes into that movie and adds things to my items. So I do items push. I'm just adding the movies to my array that actually will be bound to the UI. And I'm going to map the things that were in C# in this struct into something that looks like the thing that my data binding logic expects. So I can map the struct members onto their corresponding names in the JavaScript object. So the title will be just movie.title. And you see I even get IntelliSense here, movie.title. It knows it's an array of movies, hence the elements in the array are movie objects which are the struct in C#, which look like something that has a title. And in fact, it surfaces it using lowercase t. And I also will have the URL in here, which will be movie.boxart URL. And sometimes you don't get lucky quite yet, but that will improve. So here we go. I'm basically running through that array as soon as it arrives, pushing things into the elements collection or the items collection, and then setting it as the data source. So let me just set a breakpoint over here to actually show this guy in action. So that's the continuation of query movies async. When the movies are retrieved asynchronously in the meantime, my rendering engine for HTML5 and JavaScript can continue doing what it wants to do. You saw the UI was available. I had my title. And now at some point in the future, we got our movies back, which actually came from the C# world. Title, URL, boxart URL, all of those guys. You see them all nicely surfaced in the UI. Now I'm going to run this little iteration through my array. So the individual movie objects are being pulled out. And I'm actually just pushing them into my items collection. And ultimately, when this thing completes, they're actually sent to the UI. And there we go. Now I have objects that are coming from C# that use the Netflix OData APIs using regular .NET methods. and actually surface them in JavaScript by just a little piece of code. So that's the whole idea of Windows Runtime is you can use your libraries that you write in the languages you see fit, and you can combine it with any rendering technology. Like in this case, if I prefer to write my application using HTML5 and JavaScript for rendering, I can definitely do so. If instead I want to stay in C# or VB or C++ and I want to use SAML, I can actually do that as well. So marshalling those objects across the boundaries is something that's actually one of the essential things of Windows Runtime with regards to writing those applications. So let's actually switch back to the slides and talk a little bit more about some other features we've done in C#5 and VB11. So what's up with this thing called color info attributes? It's just a very little intermezzo in this talk. It's a little feature that we got around to add. It looks as follows. It wants to answer the question that people sometimes ask is, Jude, where are my line and file macros in C#? How many of you know from the C++ world line and file info? Okay. So it's a popular outstanding request, like I want to write some tracing code in my C# or VB code, and I want the compiler to emit the location where that method call is made and embed it in my source file. I want to know the file and the line on which certain things happen. And you get those kind of things sort of with exceptions. If you have a PDB file, you know the line in the file that things are happening, but you really sometimes want to embed that information inside your compilation unit without having to write those things yourself. This was foo.cs line 1123, whatever. Like, you really want the compiler to embed that stuff. So we don't quite want to do macros in C# or VB. There are lots of, nasty things associated with macros. It's really a can of worms, and so we don't want to go that slippery slope, but we can do something slightly better, which is color info attributes. So what I have here is a tracing class, a static class called trace, that has a writeLine method, and it takes in 4 parameters. The first of which is not optional, it's a message. And then secondly, we take in the file, the line, and the member on which a certain thing occurs. Now those 3 parameters, as you can see, are optional. They have an optional value specified, something we can do in C# since C# 4.0. And that's also part of the language parity. In VB, you could do that all your life. But what's the thing? The thing is that those parameters are not just substituted by their defaults. Because they have those attributes on top of them, the compiler substitutes their default values for information it has at compile time. So when you call this method, trace.writeLink starting services, and you don't specify the file, the line, and the member, the compiler rewrites this as trace.writeLine starting services, and it inserts, instead of those parameters, the file that this thing occurs, C sources foo.cs, 1123 as the line info, and initialize as the member from which my trace.writeLine was called. So you don't have to have those magic strings in your tracing code. You can just ask the compiler to insert the current member name at compile time. Now, this is not just useful for tracing. In fact, it's also very useful for this thing called iNotify property changed. Today, if you implement iNotify property changed, well, in every single setter of your code, you have to do something like, if the value really has changed, then I want to change the value and raise the property changed event given the name of my current property. So in H, you have something like raise property changed event with H in between double quotes. Now you can write a little helper method that takes in an optional parameter that takes in this color member name attribute, and now you can just write code raise on property changed and we'll insert the member name for you. Might be the case that you need to get rid of the set under bar thing in front of the member because you're really inside the method. But other than that, you just get your hands on the raw data at that point. So that's a very nice little feature that we actually got around to do. In fact, the design was done back in the C# 1.0 days, but we didn't want to have named and optional parameters in C# because generally they lead to API design that has methods with 50 parameters, of which 29 are mandatory and the other 31 are optional. That's not great API design, but now that we actually do have those optional parameters in .NET 4, also for office interop scenarios and those kind of things, we can now enable this feature really easily. So that's what you get over here. So now that I've looked at C# 5 and VB11, I also wanted to talk a little bit about what's next, what's going on after this particular release. So here are the themes that we talked about before. We talked about managed code, we talked about generics, we talked about language-integrated query and dynamic. Now we've added to this whole support for asynchronous programming and the Windows runtime. What's next? Well, I'm not going to talk here about C# 6 or VB12 or anything like that. Instead, I'm going to talk about a project that we've started a while ago called codename Roslyn. And so the Roslyn project has actually gotten to a point you can download the CTP and play with it yourself, and I will show it on stage in just a moment. But so the idea of the Roslyn project is to open up the black box of a compiler. Now, if you look at the C# and the VB compilers, they're a treasure of information. If you feed it some source file, what they're doing is like they're lexing the file, they're tokenizing the file, they're creating syntax trees. Those syntax trees could be used for like all sorts of great things, like rendering the text with nice colors in some places, like the Visual Studio Editor. Then it does all sorts of type analysis, it does flow analysis, it finds dead code, it eliminates dead code, it rewrites a lot of things, and ultimately it throws away all of that knowledge just to generate a .NET assembly. Like, why can't we open up the compiler so that you can actually interact with the internal data structures and write great tools on top of that? And that's actually what Roslyn does. It opens up the compiler as a service, as an API, that you can just do an add reference to in Visual Studio, and then you can just tell the API, here's a piece of C# or VB code, and please analyze it to the point of like type information, and then I want to do something with that, like refactorings and those kind of things. So it opens up a lot of scenarios, like metaprogramming, having read evaluation print loops, something traditionally dynamic languages have always had, like you can just jam at the keyboard and sort of prototype things. Now you can do that in C# and VB as well. You might want to embed C# inside some other bigger language. You might want to use C# as a domain-specific language. In fact, if you look at Windows Workflow Foundation, they host Visual Basic as a way to write rules in their rules engine. Like, why can't you do that yourself as well? Like, if you have some tool where you want people to write little pieces of C# code that you can take up as a text and then transform into some executable piece of code. And finally, we have an object model for the entire language, meaning we have abstract syntax trees, we have type information, all of that stuff, and you just get to party on those expression trees, for example, to do refactorings and other tools on top of that. So what are the Roslyn APIs look like? At the bottom of this slide, I have the typical pipeline of a language compiler. It starts with a parser that actually takes the text file, tokenizes it in little pieces, and actually creates a syntax tree out of that. Then we have some symbols that also allow us to describe, what's inside compilation units and what's inside assembly. So we can, for example, look at an assembly and see all the things that are in there, so that when you do an add reference, you know exactly what you're talking about. Then you have the binder that basically takes all your declarations together and does type checking, flow analysis, and all of those things. And finally, once all the type checks pass and all the errors have been resolved, we can start emitting IL code. So all of this now, what used to be a black box, you could just feed text in and out comes an assembly, all of those phases of the compiler now have a corresponding API you can interact with. So the parser is exposed to a syntax tree API. So you can just walk up and say, please parse this piece of text as C# or VB code, and then you get a tree out of it that says there is an if statement with this condition, the condition uses an equal sign, then there is a then keyword, and all of those things. And based on that, you can do things like colorization and all of those. We, of course, have also a symbol API to describe symbols, what's in the name. Then we have the binder. The binder does flow analysis, all sorts of things that deal with type information. So that's actually what's in the binder phase. And finally, we have the emit API. It's a little bit like system reflection emit, but it does more. And so that's the API that ultimately writes the assembly to disk. containing all your methods and all of that stuff. So what are the language services we can build on top of that? Why did we do this? Well, it turns out to implement a single language feature in C# or VB, we have to write compiler code in 3 distinct places in the product. We have to update the batch compiler, csc.exe and vbc.exe, to add the new support. Then we need to update the background compiler that sits in Visual Studio. Because if you're typing, well, you want to see red squigglies when something is wrong. You want to have all the rich information in your editor. And using the batch compiler is not very efficient. It would start the process just to compile your entire code because you just inserted a single letter. Like, the effect of a local change is something you don't want to spread by doing a whole compilation phase for every single character you jam on the keyboard. That wouldn't work. So you have a separate compiler for that. And then there's a separate compiler for expression evaluation in the immediate window. When you type some C# expression there, that's happening at runtime. It needs to interact with the CLR to compile a lightweight piece of code. That by itself is yet another implementation of the compiler features. So we don't want that. We want to have a single place where we update things, and Visual Studio is updated, the batch compiler is updated, the expression evaluator is updated. And to keep ourselves honest, this whole Roslyn thing is implemented in the languages themselves. So the C# compiler is written in C#, the VB compiler is written in VB. Self-hosting is a great trick for compiler writers to keep themselves honest and see how good the API actually is for public consumption. So some of the services we build on top of that, on top of the syntax tree API, the Visual Studio formatter, when you do Ctrl-KD to outline your code, all of that stuff is built on top of it. Colorizer that does like keywords in blue and classes in a different color. All of those things are written using the syntax tree APIs. Then we have the symbol API that allows us to write object browser technologies. So if you want to create your own object browser, just add a reference to the symbol API, and you can actually render all of that stuff. Then we have the binding and flow analysis APIs that allow to do things like renames. You're sitting on a member, you do F2, you change the name of a member. We have to find all the sites where that member is used from, and we can update it because we have all the information about your code. Visual Studio had all of this information to begin with, but now it's based on those APIs you can use yourself as well. And then the emit API will actually be used for edit and continue. Like you're editing something inside Visual Studio while your code is running, that will actually trigger a little recompile that generates IL code on the fly. So let's actually take a look at Roslyn. On this machine, you can actually download Roslyn since October last year as an add-in to Visual Studio 2010. So first of all, let's just open VS 2010 over here and take a look at the read evaluation print loop. In fact, I have some tools installed that do some performance measurement of my Visual Studio to find bottlenecks, so that tool by itself might slow down a couple of things from time to time. So let's go to View Other Windows. When you install this thing called Roslyn, what you get is a C# interactive window. This guy. It's actually starting right now. And it's a place where you can just jam C# code at us and we'll compile them. You can just start prototyping as if you're in a command line prompt. So let's actually try something. Let's add a reference using the R directive to System Windows Forms. You see we get IntelliSense for add reference. We'll add a reference to system.drawing. And now I will do var form equals new form. In fact, I even get completion just in my REPL loop, something that dynamic languages can only have wet dreams about. So I'll just do that, and we get a using statement imported straight away, and I can hit enter. Now I do have a form. A form, of course, with IntelliSense, I can see all the members on the form. I can show the form, and there you go, but it's actually sitting behind Visual Studio, so let's do form topmost equals true, and poof, there we go, we have a little form. So I'm just writing little pieces of code, and they just execute on the fly in the same session, and I can see what the effect is of the code I'm writing. I can say form.title equals hello Roslyn, like this. Oops, it's not called title. Okay, I get error messages. I wanted to prove that as well. That's just what I'm making up as an excuse for not knowing it's text, but whatever. So hello Roslyn, that's what we have here, and we can even add event handlers. I can say form.add mouse move. Ultimately, this will have syntax that's the same as the plus equal sign in the final bits of Roslyn. At this point, we don't have the event syntax hooked up yet, so I can just do the add remove methods. And I can pass in a little lambda expression that says when I have an object and an event args, do console write line of event args dot, and it knows it's, a mouse event args, and it has a location and all of that goodness. So I can hook up the event handler, and now when I start moving here, it's just going in my interactive prompt. So I can do all of that stuff interactively now, and you can do it yourself using 10 lines of code. You can add reference to the C# compiler and create your own while true loop console read line, send it to the evaluator. Like, that's really all the read evaluation print loop does inside Visual Studio, is hosting the APIs, and everything is available to you as well. So now let's show something more fancy. I can actually clear the screen here, and I can do other nice things, but let's actually open a little refactoring that actually ships as a sample with the Roslyn CTP. And it's just a refactoring that allows me to convert a traditional property with a backing field, a setter, and a getter into an auto property. The opposite way is more imaginable, but this is one that actually sees that you're just having a plain old property and you can make the code smaller. So let's run this. Now, when you hit F5 on a refactoring project in Roslyn, it starts Visual Studio as the thing being debugged. And in there now, I can start testing my refactoring that I've just written. So I have a console application 25 here. It actually uses Visual Studio, an experimental Hive that uses Roslyn. And you can see the difference here. It says Roslyn in the title. And you see that you have those lines that Visual Basic people have always had, and now we have those in C# as well. So we've been experimenting with things we can build on top of the language services to actually make VS look slightly different. So you can already see what's going on here. I have this age property sitting here, and you see this little thing coming out of my age property that says, wait a moment, this age property just reads from a field and sets a field. I can summarize that thing into an automatic property. I can just make this thing smaller. Now, how does that work? Basically, let me set a breakpoint here in VS, in the code refactoring provider. So when you do file new project in Roslyn, you can actually choose I want to write the refactoring, and we generate a little bit of boilerplate code for you. But the method you have to implement is a method called getRefactoring that, given a document, a location in the document, and a cancellation token in case VS says, I don't want to talk to you anymore, you can actually tell us whether or not you have a refactoring available for that piece of code. So let me actually set a breakpoint here, and now in VS, click on age. Poof, there we go. The breakpoint in my refactoring code is hit. It says I'm in document somewhere, and you will find the full URL over here, or the whole file info. And it will tell me what the text span is. I'm on line, character 300 in this document. And so now, what I can do is I can interact with the syntax tree API to get a syntax tree for my entire C# file. And now I can ask the syntax tree, please find me the token that's on position 300. So at position 300, I have a token 195 in my file called age. That's indeed where I clicked. That's the age property. So I have a token, I can do something, and now I'm going to walk up the syntax tree to see whether that token is actually the declaration of a property. So we're trying to find a property. We found that there is a property, and you see public int age get and all of that stuff. That's just a toString function that's just showing up there. I do have the property declaration. I'm going to check whether I have a getter and a setter. And ultimately, I'm going to return a code refactoring. And this code refactoring object that I'm returning here is actually holding on to a code action that knows how to transform that piece of code into the corresponding semantically equivalent code that gets rid of this property. So when I go to the code action, there is a method that you have to implement on code actions called getEdit that VS will talk to actually find out over here what to render in the preview. what's the target code after the refactoring? And that's also the code it will insert in the place of the original code. And so here we're actually, again, interacting with the syntax tree, trying to find out all the accessors, trying to find the containing type, trying to find the backing field. If there is a backing field, it's the pattern that we sort of expect. Then we create a rewriter, and this property rewriter is actually just a visitor over the expression tree that will transform my entire file into an equivalent file that actually has an automatic property instead. And so ultimately, this property rewriter that I have sitting here will do things like when it sees the property coming by, it will convert the property to an automatic property. When it sees a field coming by that has the same name as the backing field, it ultimately will actually get rid of that backing field in this piece of code in order to basically delete that redundant piece of code I'm not using anymore. And so when I hit F5 on all of this, and in fact, let me disable all the breakpoints, I can click on this thing, convert to auto property, and poof, the refactoring that I just wrote actually did all of the magic. I can debug it, can interact with it, but so as you can see, you can write pretty sophisticated refactorings. We actually have a talk, I believe it's tomorrow, again by Alex Turner from the compiler team, that will talk about all the Roslyn APIs that we have available. And so I don't have to switch because my slide deck is here. So in summary, to wrap up this talk, C# and VB make asynchronous programming, whether it's client-side, server-side, Metro-style apps, phone apps, web applications, much easier thanks to the introduction of asynchronous methods. Basically, take your synchronous code, find all the hotspots in there that do synchronous invocations of API functionality, make it async, and put the await modifier, or the await keyword better, in front of it. What the compiler does, it transforms your code into callbacks, and you can just step through it using F10. All of that goodness still works, but you don't have to worry about basically transforming your code inside out. Secondly, C# and VB are first-class citizens on Windows runtime for Windows 8 applications. So you can actually build class libraries into Windows metadata files, for example, and call them from inside JavaScript. That's just one of the many things you can do, and that's the one I actually showed here today. So, as I said, you can write these hybrid applications, and the Roslyn CTP that I've shown here is actually publicly available now. You can just download it. It installs as an add-in on Visual Studio 2010, and then you will actually have an experimental version of Visual Studio that loads or substitutes all of the language services for the new Roslyn APIs. And so you have the interactive prompt available, you have lots of samples of refactorings and all of those nice things. So related content, we actually have a talk about Windows runtime use from C++, if you're interested in that, by Tarek Matkour. He's in room 6. I have a talk later today about introducing the Windows runtime, where we'll actually just talk about the basic principles of Windows runtime based on a developer preview that you can put your hands on today. We'll talk about Project Roslyn tomorrow. Alex Turner will give a great talk about using this great API to analyze code and actually do much more fancy things than the ones I showed here today. And then we also have a talk called the Zen of Async, hardly recommended for people who want to use the async feature, and that should be all of you, to get actually the best performance out of the async features in both C# and Visual Basic. So with that, I'm actually at the Q&A slide. If you have any questions, we might have 1 or 2 minutes for questions, and then we have to wrap up. So are there any questions? Yep.
When you were marshalling between C# and JavaScript, your movie time was struct with public fields. Was there a specific reason for that?
Okay. So the question was, when I was doing marshalling between my C# code and JavaScript, I was using a struct. Structs are just one of the types that's supported by Windows Runtime. I could have used a class with properties as well. If you use a struct, though, your struct cannot have members other than public fields. That's one of the restrictions in Windows Runtime. So if you actually want to just share some data, like sometimes a little struct is just easy to do on the marshalling boundary. Otherwise, you can just use like regular types, and you can have like properties in there. They also project in Windows Runtime. Your type will have to be sealed, though. As if it's a class, it has to be sealed. That's one of the, the requirements for interop. Other questions? Yep.
Your C#
Okay, so the question was, like in my C# file that I had there and that I was using from a Metro-style app, I was actually using the system namespace. Does it run the CLR? It absolutely runs the CLR. So the CLR is hosted there. It's running all the code that you have with regards to all the libraries that you use in the system namespace. It's just all there. Like you can use link, you can use collection types, all of the goodness. And at the boundaries, it talks with WinRT. So the CLR knows how to talk to the WinRT style APIs to create like little proxies and projections at runtime, which are very lightweight, by the way. So you're really using all the goodness of CLR, but you actually have those full immersive touch-based applications in Win8 that you can write using it. And you get the Windows namespaces as well.
So that you also work on ARM devices?
I can't comment on any of the ARM stuff at this point. We have a blog post about it, and we have the consumer preview coming out end of February. So you can actually look on the Build 8 blog, blogs.msdn.com/b8. It's a long post by Steven Sinofsky that talks about the ARM support. So in fact, you can find more information about the programming stuff over there, and in the consumer preview, we'll get more information as well. Yeah. Other questions? I don't think so. So if you have more, you can always come to me. Otherwise, I might see you back later in the WinRT talk. Thanks for your attention.